negative 4. That was kind of confusing. Moving on to the next one, it's looking like we're going to have to do the same thing, but first let's subtract the 13 over to get 1 over 16 to the x power equals, on the right side, 64. We need to get 64 so it has a base of 16, but if you try and figure out what it would be as a base of 16, and you divide by 16, you get 4. And so what we should do is change both the left and the right ones to have a base of 4. Because on the right side, 64 is just 4 to the third. And on the left side, 1 over 16 is the same thing as 1 over 4 squared. And so we can actually change this 1 over 16 to the x power to 1 over 4 to the 2x power. That square part that was with 4 can go out and be in front of the x. On the right side, we're going to have 4 to the negative third. 4 to the third, which you can also express as 4 to the negative third. And the reason we'd want to do that is because 4 to the negative third is 1 over 64. And if you do a negative, it makes it positive. And so we're looking at, if you just put that over, you'll get 1 over 4 to the negative third. So now we have our new bases, 1/4, and then 1/4 on each side, and negative third as my other exponent. Both bases are the same, and now we can set the exponents equal to each other to get 2x equals negative 3, and you just divide by 2 on both sides now to get x equals negative 3/2. Jeez, these are not friendly. Alright, next one. Left side we got a base of 5, right side we got a base of 25. We need to change the right side to have a base of 5, so that's just 5 squared. So the right side is really going to be 5, and then 2 times the old exponent, which was 6 minus x. And on the left side we got 5 to the 4x minus 6. So now our bases are the same. We can set our exponents equal to each other and then solve from there. So we got 4x minus 6. Right side we have 2 times 6 minus x. Distribute the 2 to get 12 minus 2x. Left side is going to be 4x minus 6. I'm going to get my variable on the left side, so I'm going to add 2x to both sides. Now I got 6x minus 6 equals 12. I'm going to add 6 to both sides to get my x term by itself. So I got 6x equals 18. Divide by the 6. And now you're done. You got x equals 3. Moving over to 10. Left side we got a base of 5. Right side we have a base of 1 over 625, which you can also write as 5 to the negative 4th power. And so if I just rewrite my right fraction as 5 to the negative 4th, we actually have the same base. And so you can, since those 5's are the same, we can take our exponents and set them equal to each other. 4 minus x equals negative 4. I'd subtract 4 from both sides to get negative x equals negative 8. And since negative x is equal to negative 8, x is just going to be equal to 8. And moving on to 11, let's get rid of that. Subtract 27 by adding 27 to both sides to get 3 to this ridiculous power of negative 2x plus 10. And on the right side, we're going to have 729. So the left side has a base of 3. We're going to have to change this base over here of 729 into a base of 3. So if you take 729 and you divide by 3, we're going to get 243. And if you divide that by 3, you'll get 81. Which if you divide that by 3, you'll get 27. You divide that by 3, you get 9. And you divide that by 3, you'll get 3. Finally, So we have a grand total of 1, 2, 3, 4, 5, 6. 6 threes together to get 729. We finally have the two bases of 3. We can set their exponents equal to each other and solve from there to get negative 2x plus 10 equals 6. I'd subtract 10 from both sides at this point to get negative 2x equals negative 4. Divide both sides by negative 2. You'll get x equals 2. And that one's done. We just got a few more. 12. Something that you'd want to do on this one is make sure you get your exponential factor all by itself. So let's divide just both sides by that 12 there. So now we're looking at 3 to the 3x minus 4 power equals, well, 2,916 divided by 12 is 243. And if you look at our previous work, 243 is really just 3 to the 5th power. So that right one we're going to write is 3 to the 5th power. We finally have common bases of 3. We can set our exponents equal to each other to get 3x minus 4 equaling 5. Now just add 4 to both sides to get 3x equals 9, and divide both sides by 3 to get x equals 3. On 13, again, we need to make sure we get our exponential factor term all by itself. Subtract 12 on both sides. Now we're looking at 3 times 5 to the 3x plus 1 power equals, well, shoot, 387 minus 12. It's going to give me 375. Now just divide both sides by 3. You're looking at 5 to the 3x plus 1 power equals 125. And 125 is the same thing as 5 to the 3rd power. So we have common bases now. We can set our exponents equal to each other. 3x plus 1 equals 3. Subtract 1 from both sides to get 3x equaling 2. Divide both sides by 3 to get x equals 2/3. And our last one, 14, we need to get our exponential term all by itself, so I'm going to subtract 16 from both sides. Left side I'm looking at 1 over 49 to the 4x plus 3rd power, and on the right side I am looking at 49. Well, 49 would be the same thing as 1 over 49 to the negative 1 power. And 49, which you can also write as just 1 over 49, the whole thing, to the negative 1 power. And so now we have common bases of 1 over 49. We can set our exponents equal to each other. So now we have 4x plus 3 equals negative 1. Subtract 3 on both sides to get 4x equaling negative 4. And divide both sides by 4. And you got x equals negative 1. And you are done and good to go.